Welcome in the arena. My name's Allyson Klein. Today is a fantastic interview. I've brought together three experts from the data center domain, and they are coming in to debate a really important topic, hitting the scale wall. I'm going to get to introductions in a second, but I just want to say that we have had, for the last couple of decades, a general purpose approach to computing in the data center. And that general purpose approach has been falling apart. We're seeing a tremendous amount of innovation on every aspect of data center computing, driving different diversification, different bottlenecking all over the data center. And we're going to approach this topic and see what is the approach that is going to deliver the core capabilities that operators and AI practitioners require, and how is the industry best able to navigate the scale walls that we're hitting up against. To take this topic on, I'd like to introduce our three guests. The first one is Sandra Rivera, chair of the board at VSORA and former CEO of Altera. Welcome, Sandra.
Hello, Allyson.
It's great to have you on the show. Jeni Barovian, advisor to the TechArena and a veteran of Intel and Altera. Welcome to the show, Jeni.
Thanks, Allyson.
And Lynn Comp, global head of sales for Intel's AI Center of Excellence and a frequent guest on the arena. Welcome to the program, Lynn.
Great to be here, Allyson.
So let's just start. It's wonderful to have all of you here. You are all incredible leaders in the industry. Sandra, you are the CEO of Altera. You led Intel's data center and network businesses and have an incredible tenure of leadership in this specific domain. Your purview in tech is unparalleled. Can you just do a quick introduction of yourself and how you're looking at today's tech landscape compared to some of the tech landscapes we've navigated before?
Well, thank you, Allyson, again, and it's great to see some of my favorite tech industry colleagues on this chat. So I've been in tech for over 35 years, and I'd like to start by saying that I come to this conversation as an AI optimist. I believe in all of the wonderful things that AI can bring in terms of making our lives better and more fulfilling. But I have to balance that with the fact that, as we approach this discussion today, that there is a lens of probably eroding trust in terms of AI overall and some of the fears that people have that AI is coming to take their jobs or worse. So if we want to overcome the very real technical and economic challenges to scale AI broadly, we're going to have to address the very real concerns that a majority of the public, at least here in the U.S., have about the widespread deployment of the technology.
I love that comment, and I agree. The opportunity with AI is tremendous, and there is so much to navigate, not just from an infrastructure perspective, but also broader application and societal impacts from what is a transformational agent in society. Jeni, when you take a look at the narrower focus on infrastructure, I want to talk about the wall. And I've heard you talk about this scale wall before. The industry reached this level of scale on the backs of one general purpose approach to compute. And it turned out to be a great thing. And we all come from backgrounds that have driven this into the marketplace. When you look at the scale wall, first define it, and then what do you think breaks first about the general purpose compute approach?
Yeah, on the definition of the scale wall, there are so many different walls that we're up against. There's a lot of discussion about memory wall as far as what's happening at the system level. There's, of course, a power wall relative to being able to deliver enough power for these facilities to be built and to operate. And then there's societal walls relative to what Sandra was talking about around acceptance of the technology and the impact it's going to have on people's lives, as well as the actual presence of the physical infrastructure in communities. And this is coming from really a place of an industry where demand is outpacing supply at a clip faster than I think any of us have seen, right? This demand is very real. And there's a gap, and the gap is being made worse by a true utilization shortage. I mean, that's really what I think about when I think about the wall and what needs to be overcome. It's how do we make sure we use get the best out of the deployed resources that we've already put out there, and then of course drive better efficiency as we continue to build out infrastructure. It's certainly not a new problem, but it's very, very acute with the gaps that we're dealing with right now. Certainly one of the answers that we think about is acceleration and heterogeneous computing. And this is, of course, a tale as old as time, at least in tech, where all of us have lived our careers. You can go all the way back to like a math coprocessor paired with a CPU. And now you move through the GPU emerging first as an accelerator to the CPU, now becoming the dominant form of compute in AI data centers. And now what we're finding is what was once an accelerator now needs acceleration itself, right? So specialized workloads are demanding specialized silicon. And this is, of course, a catalyst for a ton of investment coming beyond NVIDIA-based solutions in alternative GPU and AI accelerator architectures. But when I think about where else, things are breaking, I think about kind of this three-legged stool in the system of, compute and memory and network. And if you're not going to have stranded resources, ideally all of those different types of resources are moving in lockstep in terms of their capability. And so, like I mentioned before, you're dealing with a real memory wall, but now we've got a network wall emerging, right? And as a result, you have GPUs, a tremendous amount of investment in GPUs that are sitting idle, waiting on data from memory, data from the fabric. And this is corroborated by data that comes out of the hyperscalers and the AI infrastructure operators, where they're not just seeing stranded resources during training runs, but they're also seeing stranded resources for inference. And now we've got this crossover point where the amount of CapEx being spent on AI infrastructure is now dominantly inference. We have that crossover point of training dominating the spend now to inference dominating the spend. And so this is really a problem that we have to solve moving forward. And really the other issue I think about relative to what breaks is reliability, right? You've got this need to over provision GPU clusters, sometimes as much as 20, even 30% in order to deal with the hardware failures that are happening at scale. So you've got this redundancy tax. And so if you could find a way to overcome all of these challenges, there's really a ton of capacity that could be unlocked by just focusing on utilization.
Now, Sandra, when Jeni was talking about, compute, memory, network, I remember conversations around platform delivery where the entire industry would coalesce to solve, we're memory bound. Let's advance memory. Now we're compute bound. Let's advance compute. Mm-hmm. It seems like we're having to work on all vectors at once in parallel at this point. How does the industry get their arms around that? And how do you imagine the industry can work together across all of these vectors of innovation?
Well, as Jeni describes, it really is a systems problem. And if you just go back to first principles about how so many technology disruptions, innovations, and wide-scale deployments happened over many, many decades, there's probably three themes that stand out. And I don't think that this one will be different. Perhaps the time scale is more accelerated, but it's the same three factors that I believe are essential in order to accelerate the widespread deployment and scaling of AI. And the first is open source. The second is standards. And the third, I would say, is regulation and having regulatory framework that you're working against. So from an open source perspective, clearly it's key to accelerating innovation because you tap into a broad set of parallel efforts from developers all over the world, and also the users and the use cases that, again, are very broad and vary from the largest gigawatt data centers down to all of the edge devices and now physical AI. You can innovate at all layers of the stack and benefit from, again, all of the creativity and wisdom of that collective. So open source, and we can talk later about, open weight models and some of the threats that may present to some of the closed, frontier labs models in the US. But I'm a big believer that open source always wins in the long term. From a standards perspective, it really is essential in terms of lowering that barrier to innovation, because when you have standard interfaces to which you can connect your product or service, it allows you to focus on your IP and your differentiation and gives you a landing zone for that capability versus having to do or redo all of that work yourself that maybe is not differentiated and not necessarily value add. And there's all kinds of examples here in terms of ACIE or UAL, PCIe, HBM, Ethernet. I mean, there's just so many standards that allow more innovation and more leverage of the investments and capabilities of many, many different developers. But then, lastly, from a regulation perspective, I do think that having a technology that is as powerful as AI would benefit from having a set of ground rules and a set of expectations in terms of how it's going to be utilized and how it's going to be rolled out in a way that does benefit society. And I think that, again, we can talk about this later in the discussion, but when you have no constraints, you have a lot of anxiety, a lot of fear that things are being done to you, and you're not going to get that type of systems thinking and approach and deployment and the embrace of the technology that you otherwise could if people felt like, everyone is playing by a set of rules that is driving towards the goal of technology for good.
Okay, so Sandra just painted a wonderful definition of a sandbox in which we're going to imagine the future development of infrastructure across open source, open standards, and regulatory frameworks to keep us honest. And I guess my question in this world of heterogeneity that Jeni is calling out, and a consolidation of power within the hyperscalers and neoclouds in terms of who is driving all of the data center deployments, how do we see those arenas that all of you have participated in very deeply needing to evolve to meet this moment? And what do you see changing in terms of the way that the industry works together on these important foundations for innovation? Who would like to go first?
I think I can start and then hand it off. So one of the things that's interesting is I get asked a lot, what's the best agentic AI processor that's out there? And usually it gets uncomfortable when my response is, well, what are you trying to do? What problem are you solving? Like, what is it supposed to do? And then I can tell you ideas of what might fit best. And I think that in this shift from a chatbot model where it's you query an input, it inferences the input, and it takes the output out in this model that's been trained, which is where all the money had been going for what Jeni said, we're now in this loop and it's getting applied to real work and to back office work. And so it becomes a lot less likely that you need the biggest, baddest frontier model for taking 5 vendor APIs and amalgamating the data into a dashboard of, I don't know, my data center's running everywhere, or is there a problem? You don't need the best, baddest model to tell you that. You can probably simplify it down. And I think that gets into the question of heterogeneity, right? Because essentially, you're not trying to solve every problem with one solution. The 386 was the first processor that was in a mobile phone SoC. And so literally it was a PC in your little phone. But the key to that was the accelerators, the heterogeneity, the things that were hardened because software stabilized and standards made it clear what the rules were. And that's how you get the better solutions for the problem, which helps with Jeni's power wall, scaling wall, AI wall, memory wall. I mean, we're hitting the walls all at once. So I think it's when you know what the rules of engagement are and the software settles down, you have a clarity about what problem you're trying to solve, then you can come up with a solution that balances these factors. But if it's everything for everyone in all places, you're going to keep getting bigger and bigger and maybe not hit the solution that you really need.
So I live in Silicon Valley, and there's a startup on the corner like every week. But I think this is a beautiful thing that in order to have that broad scale AI deployment and overcoming a lot of the walls that that Jeni so articulately laid out, that in fact, there is so much opportunity for innovation. There's so many new startups. There's so many parts of the problem, whether it's in compute and networking, memory, power, cooling, security. It's not that any one company has to solve it. It actually is an environment where lots of innovation is being encouraged. And in fact, there's many companies with ideas for how you can tackle parts and pieces of it. And if you're anchored in open source and open standards, then it does allow that barrier to innovation to be lowered and for more and more of these companies to come to the table with something unique and differentiated with that benefit of speed and agility, which I would say is like a superpower for a small startup company.
Yeah. Yeah, completely. It really is. How do we drive that catalyzation of the innovation? The way I like to kind of think about the moment that we're in right now is that we're moving out of sort of the mainframe era of AI infrastructure into more of a open systems era that we saw in earlier waves of the data center build out. So from, one or a dominant, very small number of companies and a single architecture kind of controlling the whole stack. It's how do we actually build what's needed for the entire set of problems that we're trying to solve? And so that's genuinely how you actually get heterogeneity. Like you're focused on open systems, not because you want to specify and build the same thing. It's you want to build open interfaces so that you can build specialization to solve different problems in different areas, but still get interoperability of all that great innovation that you've catalyzed within the marketplace. But I think where we're at right now is you've got a lot of open forums and discussion happening at the hardware level, at the software level, hardware level in places like Open Compute and UA-Link, Ultra Ethernet. Sandra, you were talking about some of these open models, open source software communities. And there's a lot of activity there, but, particularly as it relates to the hardware innovation, there, at this stage are a lot of people showing up with the same mixed motivation that happens always in communities where it's like, okay, I want to do good for the community, but I want to do good for myself and the solution that I'm offering, right? And so I don't think we've reached that tipping point yet of focus on the good of the community in order to spur that true move over to an open systems type of approach. But we know it's needed. We know that that's exactly what's required to achieve the same level of innovation and scale that we saw, of course, in, kind of the first wave of the data center build out. And so how do we get to that point where open common interfaces flourish and allow that specialization to then flourish in turn?
One thing I do love to point out, because you guys having the Altera background, I mean, what's the first version of every phone that comes out? It is not a tiny phone. It's a massive motherboard with a bunch of FPGAs testing out the algorithms. So I think that in the AI world, you're still going to have this space where the mainframe exists, because mainframe still exists in data centers. But the path to multiple solutions and miniaturization and the right solution for the right job is still one that we're getting towards.
But I think you set me up well, Lynn, because what I was going to say is that, you have a path to drive more brute force compute with innovation, but you also have a path, and Jeni, you've written about this very eloquently, to drive efficiency and sustainability in the compute that you have, and drive, more tokens per watt, if you want to think about it that way. How does that look in practice, Jeni, to go tackle driving more efficiency into the infrastructure?
Yeah, I mean, there's so many challenges that need to get addressed. You need to actually figure out what heterogeneous compute looks like. You need to figure out what the orchestration and the scheduling looks like to actually route the workloads to where they need to run. You need to innovate in networking. You need to innovate in overcoming the failure rates that I was talking about before and ensure better resiliency and availability of these systems. Heterogeneous compute, we've talked about it a couple of times now. I love that Lynn brought up specialization and dedicated acceleration for networking functions, right? There's all kinds of things that, even if you have a general purpose processor that's running, the core of the workload, you've got accelerators that are running other functions. Like we've been, I think, alluding to in this entire conversation, it's really clear that AI infrastructure, and particularly AI inference, is definitely not one size fits all, right? And NVIDIA themselves, right? At GTC this year, they were showing, Rubin GPUs paired up with Grok racks that were handling different tasks within the same inference pipeline. And the same thing's happening with all the hyperscalers innovating their own silicon at the core compute level, as well as specialized acceleration, and really kind of increasingly relegating GPUs to the things that they're best at, which is training, right? And so you start to see a lot of this breakout and specialization as it applies to this burgeoning inference market opportunity. In terms of networking, there's a tremendous amount of investment right now in solving the optical layer, right? You've got optics pervading, already inside the data center, right? Not just for true long reach, but inside the data center, now moving into the rack. And that's wonderful, and it's needed. We need that innovation and silicon photonics and co-packaged optics. And it's really the answer for, the best raw bandwidth, because copper's hitting these physical limits. But you have to really solve the entire problem all the way up the stack, from silicon all the way up through software. The physical layer and the focus on optics isn't enough. You need a robust logic layer also driving it, solving problems like congestion and adaptive routing to make sure that raw bandwidth increase is really transformed into usable scale and reliable scale. And that's not just today's problem, but, we talk about more of a dominant move over to disaggregated architectures where you're going to have separate pools of compute and memory and storage. And so the stakes on the network become even higher. And then I guess just last thought, because I mentioned resiliency before, you've got a lot of hyperscalers reporting abnormally high termination or slowdown rates on resource intensive workloads. And it's impacting user experience, and we see this pattern across the board. And, hardware failure has just kind of become the norm. That's why you have to build in, those hot spares and that fleet level redundancy. And they basically built that into their operating model. But the question is, how do we overcome that, right? How do we focus on better failure detection, prediction, and prevention of errors, and better failover, and really drive to a mode where we don't have to over provision to the degree that we are today in order to drive better efficiency of the overall infrastructure.
Sandra and Lynn, any comments about Jeni's perspective here?
I'm just so grateful she mentioned the resiliency and the redundancy, because you look at the sensitivity to failure rates that the hyperscale industry has historically had, then driving their vendors and suppliers to have telemetry down to the minutia to give predictor failure management, so that they could orchestrate the shift of a workload before there was a failure rate. And here we are, it feels like we're back in the early 90s, back to, we're in the middle of a training run 2 weeks in and something failed and we have to start over again. So I think there's practices that have been put in place for many years that just need to be brought back into these new heterogeneous domains that maybe we were racing so quickly to build out. We weren't necessarily looking at how do we manage well. And that's going to be a huge question moving forward, especially as AI is going into enterprises where there are certain levels of accountability and insurability, and you have to have correct answers, and you can't fail in the middle of certain transactions. The getting out of the R&D mode into the mass market mode is going to cause some changes to happen, I think.
Yeah,
Now,
just plus one.
Yes.
Like that. And truly, I think we've gone through the cycle of FOMO, where everyone was doing a lot of testing and pilots and proof of concepts, and just throwing money kind of brute force at the problem, and trying to come up with an AI strategy as an enterprise. And I think all of that was very well intended. And I always hear Andy Grove in my head of let the chaos reign, and then reign in the chaos. And I think we're very much in that reign in the chaos stage, where CEOs and CFOs and boards want to know what is the actual positive business impact on either the financials or customer acquisition or customer satisfaction or new market entry that is being driven by the implementation of AI across the enterprise. And so I think that at this point, that the need for metrics and deliverables and outcomes more so than the input process of, are you getting people, trained up and using AI? What is the ultimate goal of the organization, and are you achieving those goals?
Mhm.
Now, one of the walls that I think about quite a bit is the network wall. And I just want to talk a little bit about it from a perspective of distributed computing. When people hear distributed computing, often they think about edge and cloud or multi-cloud. But we're also seeing distributed computing from a standpoint of within a cluster or across clusters within a data center. Within both of those contexts, there's limitations in the network today. Um, how are we addressing this, Lynn? I'm gonna turn towards you on this one. Um, are we looking at the network to do too much? Is the network industry innovating at a rapid enough rate to deal with the distributed computing requirements? And is data getting stranded, leaving compute sitting idle?
So I'll answer the last question first. Yes, data is stranded, leaving compute to idle, and it's been happening for so long. I tell people jokingly, here's your investment tip. Basically, if you've already had a huge build out and you can't get the compute resources and memory is, would you want a gold bar or would you like a memory stick? It's kind of a toss up right now. Then the next one is going to be networking because, you've got to move things between these 2 points. So yes, it is a huge issue. I think to some extent, because of the verticalization of this industry, like every industry starts vertical. They're all trying to get this system running very efficiently within this one vendor reality. But then as standards come and pressure points hit, then you're going to have more standardization where there are better alternatives in more of a open standards system level, like what OCP is trying to drive. So they're coming. I don't know that we're there yet, but optics is absolutely something that's the next space. And then the question is really, you're dealing with a completely different medium and breakage and replacement and there's a lot to deal with in that shift over, but that's really sort of the only place we have left because copper is, when you're at the physical limit, you've got to go somewhere else. And so optics will be next. The question is, how far beyond the walls of the data center can that easily go? Are we at the point where we can go into laying more of those cables again? Will fiber have this broad thing, or will it again be concentrated to the switches and the backhaul and the interconnects that are existing and held only by the largest infrastructure providers?
I'm going to give you guys a bonus question that wasn't on the sheet. When we think about standards, and Sandra talked about open source and standards from a standpoint of foundations. One thing that I think about is the speed that standards organizations work to set a spec and to test out that spec, and the speed in which innovation is happening right now. Jeni, you've worked on the board of OCP. Sandra, you've been involved in so many standards efforts that I don't even know how to name them right now. Lynn, you and I first met 2 decades ago around a standard, and I know that you have worked on a few since that point. When we think about standardization and we think about what the industry needs to do to drive standards-based innovation, is there an approach that needs to change in the way that we are setting our industry standards and refining them over time? And if you look into the open source arena, do we see parallels between hardware standards in the way that we need to approach open source software innovation?
What I will say is that the standards efforts are always that double-edged sword, Allyson, right? That it is important in the long run, but always feels so bureaucratic and slow in the short run. And the way that I've seen it move faster has been when a set of industry leaders, and by leaders I don't mean it has to be the biggest, most well-capitalized companies, but leaders that are voices in the industry in whatever part of that technology spectrum the standard focus may be for that group of people, that there is benefit in establishing a starting point with some de facto standard, or putting together a proposal and a first draft of a set of specifications and and capabilities that you want to galvanize a community of developers around. And we do have many examples, and certainly the four of us actually worked on network transformation and NFV for many years. And it all starts out with just a set of leaders deciding that we're going to try to catalyze an industry to move forward faster. And in many ways, all of that backed into the more formal 3GPP standards and IEEE standards and all of the other ways that standards have evolved for many years. But I don't think that at the speed at which we're moving with AI that we can afford to take the slow and steady route. But it's more of a parallel effort of getting going, putting something forward, galvanizing interest and support and contributions, and then perhaps more formally establishing that over time. In many ways, it's the way OCP has evolved over the years. DC at MHS is something we worked on together as well. It starts as an idea, a set of interested stakeholders, technical leaders, and then you demonstrate the benefits of that approach to the broader industry, and they ultimately come on board and improve that standard and really crystallize it for the rest of the industry.
Yeah, I completely agree, Sandra. And you've got to start with something other than a blank sheet of paper, right? Because the reality is that when you get that small group of motivated organizations together, it's because they see the same problem and they also believe that they can be part of the solution. And I think that really motivation is the other key element of that, and commitment. As I said before, I don't think we've reached that tipping point yet with open, focused AI infrastructure. I'll say communities, right? Because standards takes it a step too far, I think, for a lot of just the open systems oriented work that is going on, where there's a little bit, not quite the right balance yet of, these organizations are in it for themselves and their own success versus being in it for the value of focusing on supporting what the community needs in a lift all boats type of mindset, right? And I think once we reach that tipping point, that's where you're going to see the catalyzation of the open systems approaches to a greater degree as it pertains to AI infrastructure. But it's really that motivation and that mindset, but that initial commitment, right? It is a resource commitment to come together and really decide, okay, I'm going to focus more of my attention on coming up with a community-based approach and an open approach that may mean that I have to make my own compromises, right? And that's really what it boils down to. Yeah. And we'll get there, absolutely, right? We're on the cusp of this transition to an open systems approach.
Yeah, I think that right now we are everyone's trying to become the de facto standard as fast as possible. So you've got a lot of attempts at being the de facto standard. None of which are actually going to raise all boats and grow the business and achieve the breadth of the business success that a whole industry could see. Like if you look at the .com and the internet, there was a lot of agreement that had to get reached so that you could finally solve the last mile problem, and the payment systems and the delivery systems and everything else was there to make the overall vision realistic, because it wasn't going to happen with just 3 vendors. And so we're in that mode of everyone has I'd like mine to be the de facto standard. The question is, when are we going to collectively as an industry come to the realization this gets a lot bigger and a lot more useful if we can agree on some fundamentals of how these things connect together and then how we're going to interoperate, because it's just going to be a reality.
Now, I want to change focus points. And Sandra, you in your premise brought up regulatory control as well. And there's been so much in the news around data centers from and AI, from, is AI going to destroy the world's job markets, to are AI data centers going to consume the world's energy? We've heard communities not wanting data centers in their environments. We've heard different labor organizations raising concerns about how AI is being implemented in the workforce. And, this is such an important way that we bound the deployment of this strategic technology, and that we look at how we utilize it in a way that's both mindful of the broader sustainability and energy challenges that are driving its utilization, and also its use within companies and with society as a whole. How do you see this evolving? You spend a lot of time in this space. Tell me how this is landing and what we should be looking for from a standpoint of those shepherds in the industry that are carrying this technology forward.
Well, I don't think it's surprising to get pushback when you've spent a lot of the last several years telling everyone how AI has the potential to wipe out humanity, take all our jobs, and maybe, sprinkle in there a cure for cancer in between. So people are going to be fearful and they're going to push back. And I think a lot of this has been self-inflicted wounds, truthfully, because the way that these data center build-out have been happening have been lacking in transparency. So it's been well documented by the New York Times, Wall Street Journal, Forbes articles around the NDAs that have been required for a lot of this data center infrastructure build-outs, these very large gigawatt data center builds in different communities. There's a lack of inclusivity in terms of the ratepayers and members of the community. So they're, of course, want to be included in something that's going to impact them, whether it's noise, whether it's use of precious resources like water, whether it's enhancements to the grid that are required for which they think they're going to be on the hook to pay in increased utility bills. So it's just this sense that the builders are not paying their fair share. They're not including the communities that will be impacted. And it just breeds a lot of suspicion and anxiety and ultimately pushback. So I think if you were to flip that and say, how do we get more of at least the public in the US more excited about AI? And it's really stark because in China, 70% of the population thinks AI is going to have a positive benefit on their life, and only 30% are more concerned about it than not concerned. And in the US, it's the exact opposite. Like 70% fear AI and think that it's going to have a negative impact on their lives, and only 30% are excited by it. And I think that we're going to have more specifics around how those jobs that are replaced by AI, how those people are going to be impacted, retrained, reskilled, how there's going to be a real investment in the communities, how they are going to enhance the tax base and the infrastructure in terms of libraries and schools and emergency services for many years. And there has been more recently an attempt to address some of these concerns. Just a few weeks ago at the White House, there was actually about 200 companies came together to sign off on this ratepayer protection pledge, which is voluntary, but it's a step forward where the data center builders and the ecosystems supporting those bills are committing to paying for what they use, including any grid upgrades. They're paying whether they are going to use all of that capacity or not, and signing long-term agreements so that communities that are investing their own resources in these projects know that there is future protection and certainly from utilities as well. And I think these things are really important, and we're going to change the narrative and the mindset around AI and be more supportive around these data center infrastructure builds, which are required for us to lead in a technology that is so disruptive, innovative, but with a promise to do so much good in the world. It won't happen. We will not overcome that scaling wall if the citizenry isn't really trusting of the government and the people that are deploying and building out these very large data centers. And I think that just a more thoughtful approach to do it with the communities is going to go a long way for us to not have a lot of the backlash that we're seeing today.
Jeni and Lynn, any other comments on Sandra's perspective?
The power stuff, it's just real, right? We have to change the way that the interaction between the data center operators, the utilities, and the communities are engaging with one another. We know the demand is real in terms of just overall AI data center build out, but it's not being properly quantified and articulated in the demand signals that the data center operators are giving to the utilities in these different jurisdictions, right? It is far in excess of what could ever actually be built out because they're using it almost as an auction process to figure out where to do those site placements, right? And so the utilities are, have copped to that, and they're like, okay, this can't be the way we operate, right? We need legitimate demand signals. And so it's really great to see the type of actions that Sandra talked about, right? The agreement, with the White House, and this commitment to obviously protect ratepayers, right? Consumer ratepayers who are very dramatically impacted by the technology in a number of different ways, but also just find better ways to collaborate with one another. And I'm glad you also raised the concern about the NDAs. I mean, look, we all worked for large companies. We understand the value of protecting IP. However, there needs to be a certain amount of collaboration to ensure that the level of build out can actually occur in an effective manner, because the operating model doesn't really support it today. And so whether that's ponying up the expense for the CapEx outlay, and also the operational expenditures, and then also finding ways to collaborate more openly across different operators and utilities who are delivering that service and capability. And of course, there's innovation happening at the data center with the data center operators themselves, innovating new energy generation and storage and transmission technologies. All of this needs to come together to solve the power wall. So a lot of what Sandra said resonated with me as well.
Yeah, I would just add in from the regulatory standpoint, there's another angle that I've seen also. I mean, the Supreme Court and other appellate courts have made pretty clear their view of when you use AI tools, do you own the copyright? Or what's required for you to own the copyright? Another great example, when, it's sort of like you watch the risk adjusters and what do they think? And there are carve outs in insurance policies for businesses who are using AI, that if there are damages in certain uses of AI, agentic AI, autonomous AI in particular, and there's damages, the policy doesn't pay. And so, you look at this and think, this might be ripe for regulatory questions that might come into bear. And do we have the right generally accepted accounting practices? Do we need to tune those up based on how these investment vehicles are working? So I think that, yes, there's this whole technology, there's this whole physical regulation of how do we get along with one another between the technology vision and the people who have to live with it. And then there's also the other regulatory environment of how do you report things? How do you recognize revenue? How do you adjust for risk? How do you maintain identity? And all of that is still very, very new.
I do feel like we are navigating a labyrinth of walls right now. And as you guys discussed, the thing that I hear about is the layers of complexity in terms of solving the moment that we're in tech. I also know that we've got over 100 years of experience collectively on this panel in the industry. And I think that we all deeply believe that if the community comes together, we can solve this together. So my final question to the panel today is, if you wanted to see one change that the industry tackles in the next year to get us through the macro challenge of the walls that we're describing today, what would be your choice for the thing that you think the industry needs to coalesce on to move us forward? And Sandra, why don't you go first?
Well, I think that as technology disruptions often are, they are overhyped in the short term and underhyped in the long term. And from my perspective, there's no question that this is going to be an extraordinary disruptive technology with the potential to do so much good in the world. And I would say the one thing that I would encourage all of us as practitioners and leaders in the industry is to demand and expect and practice more collaboration with the stakeholders and the communities that will be impacted, hopefully for good. And let's try to avoid some of the potential downsides and consequences by being very aware and clear-eyed about the things that can go wrong and mitigating against them from the get-go. And I think if we can do that, we will get more innovation, more embrace, more participation, and more widespread rollout of something that could be just an extraordinary capability for the good of everyone.
Lynn, next.
So I think the one thing that I would love to change is that the individual solution providers would start viewing the fact that the industry opportunity is larger, whether you're talking about model interfaces, you're talking about model weights and openness around that. Whether you're talking about interconnect or even some of the hardware standards like in networking and the OCP standards, the industry overall is bigger if we were going to collaborate and then agree on what the interfaces are and how things are going to interconnect. So for everyone's shared interest, let's all decide here's the rules of engagement on these interfaces and the delineation. So the basis of competition isn't racing for proving I'm the real de facto. It's more, let's have some standardization so competition can reign. Let a thousand flowers bloom, as Andy Grove would say. And then may the best suppliers win. But you're not debating over who wins the vertical. You're actually looking at how do we make this useful across the board.
Jeni, you're on clean up.
Clean up. Maybe I'll end where I started, which is a focus on utilization. And I think in terms of like a short-term win, if we could achieve this, would be to evolve the way that we measure ourselves and measure progress, right? We've got this kind of move in nomenclature of data centers being called token factories now. And that's now seen as, it's not, okay, how many GPUs did I deploy? How many flops? But, okay, how many tokens, can I generate in terms of like, okay, is there a payoff here in terms of the investment? And so that idea of token density is, that's achieved on the hardware side, on the software side, how much useful output you're getting out of this infrastructure that you've deployed. But you can also game that too, right? If the industry incentive becomes producing more tokens, then you run into these problems of, overthinking, where models are burning enormous amounts of tokens on simple questions that don't have any benefit in terms of accuracy. You're running 2x, 3x, even more the number of tokens to just solve simple problems. So we can't focus on volume. We really need to be measuring the other side of it, something closer to cost or compute per correct answer and per useful outcome, right? Not just the volume of tokens. And that's really where you have to start to drive innovation in the models, in the software, alongside the hardware utilization and the output of these data centers. And that really gets back to what Lynn was saying around right sizing the models to the task and being able to enable smarter reasoning and not padding just because you want to, have a headline number in terms of number of tokens. So you've got token density focusing on what the infrastructure is producing, but we really need metrics around efficiency to tell you if the work that you're doing is actually worth doing.
That is a great way to end this great debate. And, I think that one of the things that I'm thinking about is that I have so much writing to do from this discussion, because while there is token density in the world, there is also insight density. And that was expressed in this discussion. I will be writing some of my insights that I took away from the three of you in upcoming weeks. But it was a great conversation. So thank you to all three of you for being here today. One final question for you. Where should listeners go to follow what you're talking about and engage further in the discussion with you? Lynn, do you want to start?
Sure. LinkedIn for daily updates and TechArena, of course, for longer form contributions.
Sandra?
I keep a low profile. LinkedIn, you can hit me up there.
All right. And Jeni?
Of course, TechArena. I'm going to be a bit of a broken record, but yeah, go to techarena.ai. We've got all kinds of exciting content and developments coming, and you already teased it, Allyson. So check us out there.
All right. Well, thank you so much, everyone. That wraps another great debate.